Exercise 3. So here we have an exchange economy with two goods and two agents, where we have 10 units of first good and 10 units of second good. So it's written here on the right. The total endowment is 1010. And then we also have that these agents have the following utility functions. So we have to calculate the utility level of both agents when the quantities of good 1 and 2 held by agent A are the following. And basically here we have to analyze what are going to be the utility levels of both agents when they have these respective allocations. So basically then we will also have to see if some allocations are better than others, so if some of them are Pareto efficient and some of them are not. So we are solving A, and the first allocation is when we have that agent A, that agent A has all goods in this economy. And so also, so on the left I will write what concerns agent A, and on the right I will write for B. And so if the first agent, the agent A, has all goods in this economy, then agent B has nothing, because in total we have 10 and 10, and so B is left with 0 and 0. And then we have to calculate what are going to be the respective utility levels when they hold so many units of good 1 and 2. And so for this you just have to substitute these allocations, so 10 and 10 in case of agent A, into his utility function. So you substitute, that's 10 and then times 10, and then that's square root. And so we see that utility of agent A will be 10, and utility of agent B, so again you just have to substitute this allocation 0, 0 into his utility function, and so it's going to be 0 times 0 will be 0. Okay, or maybe do like that. I'll just divide here into 2. Okay, so that was the first case. Then we have the second case, where we have that agent A will have 4 units first good and 6 units of second good. And so from here we can deduct what agent B is going to have. So it's 10 minus 4, it will be 6, and 10 minus 6 will be 4. And so then again, to see what will be their corresponding utility levels, you just need to substitute these values into the utility functions. And so we have that it's square root of 4 times square root of 6, so it's like that, and it's approximately 4.9 for agent A, and for agent B is just 6 times 4, and it will be 24. Then we have the third case, where agent A has 3 units of first good and 3 units of second good. And for agent B, so again we just see that in total we have 10 units of first good in the economy, and so agent B will be left with 7 units of first good and 7 units of second good. And then the respective utility levels, so we have that it's square root of 3 times 3 is going to be 3, and agent B will just have 7 times 7 will be 49. Then we have case 4, and here agent A has 1 unit of first good, 9 units of second good, and so agent B has just the opposite, 9 units of the first good and 1 unit of second good. And then we just again substitute, and we get that it's 3, and for agent B it's 9 times 1, and so it's 9. The next case 5. So here agent A has 4.5 of the first good and 2 units of the second good, and so agent B has 10 minus 4.5, so it's going to be 5.5 of the first good, and 10 minus 2 will be 8 of the second good. And then again we substitute, so it's 4.5 times 2, so it's square root of 9 will give 3, and oops, I don't know why, sorry, I just noticed here it should be utility. Okay, and then for agent B again we substitute, and so it's 5.5 times 8 will be 44. And then the last case, so agent A has 0 and 0, and so agent B will have 10 and 10, so we'll have all the endowment of the goods in the economy, and so utility of agent A will be 0, and of agent B it will be 10 times 10 will be 100. So here we have solved A, and then we have question B. So question B, actually I will just write here where we solved. So for question B we have to answer, so we have to look if some of these allocations Pareto dominated by others. And so you remember that Pareto efficient is when it's not possible to make someone better off without harming others. But if we can do so, if we can find allocation where one of the agents will be better off without any cost to another, so basically when one of the agents will have higher utility level than in another location, but agent B will have kind of the same utility level or also higher utility level in another case, then this allocation will be better, more efficient, and that one will be Pareto dominated. And so let's take a look. So what we see here is that actually case 4, so actually case 4 here we have that agent A has utility 3 and agent B has utility 9, but when we compare it with the case 3, actually we see that agent A has the same utility as in case 3, but agent B has lower utility level. And so when we compare 3 and 4, actually 4 is Pareto dominated by allocation 3, because we see that utility level of agent B is higher and agent A in that case is not hurt, and so he has the same utility level. So actually it's possible to allocate in such a way that agent B is better off without harming agent A. And so we can write here that this one is Pareto dominated by the third case, third allocation. We see that third allocation is better because agent B can be happier without any cost to agent A. So that's that one. And we also see that it's dominated by 5, because again, so by 3 and 5, because in that case we see that also A has 3 utility level and B also has higher utility level, and so yeah, 44 is higher than 9. And then we can also compare 5 and 3 and see that 3 is better than 5, because the same logic, we have that utility level of A is 3 in both cases, but utility level of B is 49 versus 44. So again, the third case is the best one out of these 3, because we see that that when agent A has the same utility, agent B can actually have higher utility, or he has in 3 comparing to the other 2 cases. And so here we say that it's Pareto dominated by 3. So here we can just compare these two in very straightforward way, but of course we cannot compare right away if it's better that let's say we have 5 and 6 and we cannot compare in such clear way that agent A has 3 versus 0, but B has 44 versus 100. And so here, without adopting some additional assumptions, we cannot say that it's best that B has 100 versus 44, that it's better. I mean, we cannot say that, let's say, utility of B is more valuable than utility of A. I mean, if we adopt such assumption, then yeah, we can say so, but otherwise it's not straightforward. So we just cannot compare right now what's the best, but we could compare these 3 cases in a very straightforward way. Then we have point C, and here we have to represent these allocations in an Edgeworth box, which allocations belong to the Pareto set. So for this, I will have to draw the Edgeworth box. So it will be so the width is going to be 3 and height will also be 3, so it's 10, so it's 10 and 10. Okay, so we have such square where we have 10 and 10, and then we have agent A and agent B, and so different allocations that we have first, that's 10, 10 and 0, and so the first allocation is this one here, so it's maybe I will just write the letters, the numbers, so it's 10, 10 of agent A and 0, 0 of agent B. Then we have the second allocation is going to be 4 and 6 of the first agent, and so it's 1, 2, 3, 4 and 6, 6, 1, 2, 3, 4, 5, 6, yeah. Wait. It looks like actually I have here not a square, but okay, so square is going to be like that, sorry. And so we have first allocation is here, then second allocation is going to be here. So agent A has 4 and 6, and agent B will have also 6 and 4. Then the third allocation we have 3, 3 and 7, 7, so it's 3 and 3. And agent B has in the same way 7 and 7. Then allocation 4 will be 1 and 9, so it's 1 and 9, so it's here. And B has 9 and 1. Then 5, it's 4.5 and 2, so it's 4.5 and 2, so it's here. So that's 5, and then 6, the last one, that's here. Okay, so here are all allocations, and then we also have to find which of them belong to the Pareto set. In order to do that, first we have to find the Pareto set. And so you remember how we did it. So Pareto set is going to satisfy the condition that margin rate of substitution of A should be equal to the marginal rate of substitution of B. And so we just have to find the margin rate of substitutions. So maybe I will continue here. So we just take their utility functions and we find their margin rate of substitutions. And then we also have that condition that consumption of the first good in the economy should be equal to the total endowment of that good in the economy, and the same for the second good. And so by combining these two together, we are going to have that so we just substitute the consumption of B by consumption of A, so basically everything that is not going to be consumed by B will be consumed by A. And so then we have to solve this one. So we will continue here. So first we are going to multiply in such a way and so we get this one here. So here we can simplify these two and we get that it's 10x2 should be equal to 10x1. So we simplify once again, and Pareto set is such that x2 should be equal to x1. So Pareto set is when the consumption is proportional, and so A consumes in such a way that, it's Pareto set when A consumes equal quantities of A and B, of good 1 and 2, and the same for B. And so then we can see which of them are Pareto optimal. So we just basically just need to substitute like the numbers inside of the Pareto set, and you see if it's satisfied or not. But in this case it's pretty straightforward. We just need to see that x1 should be equal to x2. And so here we can say that so the first one is Pareto optimal because we see that A consumes 10, 10. Then the second one is not Pareto optimal. The third one is Pareto optimal. We also saw that the Pareto dominates 4 and 5, which are not Pareto optimal. And the last one is in Pareto set as well. And so graphically, Pareto set is just a straight line where x1 equals to x2. Okay. So that's it for this exercise, and then we will solve the next one, which is 4.